All right, we're looking at the form of the equation called the slope-intercept form of the equation. It's y equals mx plus b, and if I write that y equals mx plus b right above the given equation, it's going to make it easier to determine what m is and what b is. B is the y-intercept, b equals 4, I'm going to write that in here, and the slope is m. Right above there, it's -3. So it's the number before the x. Slope is the number before the x. Slope is also known as m. It's also known as rise over run. And it's also known as the change in y over the change in x. We'll find out more about what that means in a moment. It's in math, it's written as with a triangle, change in y, or delta y, over change in x, delta x. This is also known, this y-intercept is 4. It's also written as an ordered pair 0, 4, with the x-coordinate being 0 and the y-coordinate being, okay, x is that and b is that, 4. Now, how does that work when we're looking at a table? We need to be able to go, in graphing equations, you need to be able to go from an equation to a table and then also to a graph, and vice versa. So these three things work together: an equation, a table, and a graph. Sometimes you're given a graph. Then you have to go to a table and an equation. Or you may have to go straight from the graph to the equation, and you may or may not be asked to break a table. Whatever the case may be, there's a constant interplay between the equation, the graph, and the table, and that's something you'll have to master. Let's look at now, we're going to go individually into each one of those little boxes here and look at how each one of those works, and then look at how they work together. So without any further ado, we've talked about the equation and how to derive information from the equation. Let's look at what happens when we create a table. We have two variables, x and y. All right, x and y, let's zoom in. And x and y are dependent and independent variables, domain and range, otherwise known as domain and range. The x value, you get to choose it. So let's start with probably the most common choice is 0. Let's start with 0. If x is 0, then what is y? Well, we have to solve the equation with x equal to 0 in order to find that. So y equals -3 times x, in this case 0, plus 4. And when we solve that, we get y equals 0 plus 4, which is equal to 4. And that is no surprise, because we already know the y-intercept is equal to 4. And notice that connection between this and this. Now, if we take the number 1, we plug it in, y equals -3 times 1 plus 4. We get -3 plus 4, which is equal to 1. There we fill that in for y. And so on and so forth. If we get 2, we're going to put it in, y equals -3 times 2 plus 4, and that equals -6 plus 4, which is -2. And let's also look at what or how this function behaves when we go and give negative numbers. So let's take -1. Y equals -3 times -1 plus 4. It's equal to 3, because a negative times a negative is positive, and that equals 7. So the function behaves, or the relation behaves differently. This y value shows us how it behaves once we put in an x value. This is called the domain, and it's related to the word domicile or home, and this is called the range. So if you think of a range, if you think of a farmhouse, this will be the points on the farmhouse. This is what's happening at home, and this is what's happening on the range. And it shows you how far you can range, literally. When you put in 0, you get 4. When you put in 1, you get 1. 2, -2. -1, 7. If you continue to put points in from the domain, you'll get points over here, and the graph is going to reflect what it looks like. Let's have a look at the graph after we put one more point in, -2. I'm going to do it in my head. That would be 6 plus 4 is equal to 10. Now let's have a look at the relationship between the table, the equation, and the graph. And here it is. Go to the graph. First of all, we know the slope, right? We have the slope because we figured it out from before. It's equal to -3. I'm going to write -3 over 1. You'll see why in a moment. And the y-intercept, I'm going to put it as the point 0, 4. Okay, the y-intercept is 0, 4. And we have some points over here from our table, and we can start to plug them in. The first one was 0, 4. I'm going to plug in 0, 4 and label it 0, 4. And the next point was, I'll zoom in here and you just have to trust me that these are the points from the table we just did. 1, 1, right here. And then 2, negative 2. Remember, notice that I'm always calling out the x value first. All right? X is, 2 is the value going in, and negative 2 is the value going out. Negative 1 is down, and then over 7. So 1, 2, 3, 4, 5, 6, 7. And negative 1, that was over here. And then negative 1 and 7 was up here. And then negative 2 gave us 10, that would be up here. And then we have ourselves a line. You can put those points together on a line like this and just connect them. And they're going to go off into space, right? So we can put an arrow indicating that goes off into infinity. And there we go. Well, what happens now? Well, we're asked to find, we know the y-intercept and we know the slope. Let's look at this as a staircase. Slope, as we know, as we said, is the change in y over the change in x, and that is, if you see it on the staircase, goes down 3, negative 3, and over 1. So down 3, over 1. And that's going to happen each time. So down 3, over 1. Down 3, right, or over 1. And every time we go down, we're going to create a little staircase going down that shows the slope. And we can continue this all the way down, and we're going to get more points. Down 3, right 1. That's how the slope works. So if you're asked to take something from an equation to a graph, then, and you don't have a table, you're going to have to start with one point, in this case the y-intercept, and then use the slope information to get to the second point. In this case, it says minus 3 over 1, so it will be down 3 over 1. Down 3, right 1. If you have positive 3 over 1, it would be up 3 to the right 1. If you were to have negative 3 over negative 2, then you could do negative 3 down and then negative 2 to the left. So you've got to go with the direction that the slope is telling you. It's literally telling you negative or positive. Negative is down or left, and positive is right or up. And you're always doing the y value first and then the x value. Now that's a little counterintuitive. It's a little difficult to remember if you, because you go xy when you plot a point, xy, 1, 1, and 0, 4. But when you're doing the slope, you're calculating the change in y over the change in x. So it's a bit of, you've got to make sure you're clear on that. Are there any questions? Well, let's look at this question right over here. Let's look at this question over here. It asks us, the graph of the function contains the point. The easiest point to talk about would be 0, 4, the y-intercept. And when the value of x increases by 1 unit, the value of y decreases by 3 units. So that's how that works. Any questions?